Hi everyone, so it's Coach Fred here and I'm looking at the rational fractional exponents practice worksheet. A few of you asked about a few questions, so I made a video to go over it. So for number 17, this section is really just basically saying to you that all the rules of exponents for rational numbers actually also work with irrational numbers. So that means that if you have power times a power, you add the exponents, power to a power, you multiply the exponents. And if you're dividing, remember we bring the smaller to the larger and subtract. So those rules will apply regardless if the numbers, the exponents are integers, fractions, or even irrational. So someone asked about number 17, and the thing about exponents, the laws of exponents is the big thing is the bases need to be the same, and these are not. So in our minds, we have to decide, okay, how can we make those bases the same? Well, 25 can be rewritten as 5 squared. So the bases then would be the same, raised to the negative root 3. Then you'd use the properties of exponents, which would mean power to a power, you multiply the exponents, giving me 5 to root 3 times 5 to the negative 2 root 3. Okay, now we have power times a power, so we add the exponents, giving me 5. So 2 root 3 minus 2 root 3. If we add them, that's going to give me 5 to the 0. And then we know anything to the 0 power is 1. All right, so that's number 17. Questions 18, 19, 20. I'm asking you to really think a little bit. So I want to give you some time to do that. I recognize number 21 might be a little bit harder, so I'm making this video to help you. All right, so it says, suppose you have a function e of x, and it's defined for all real numbers. And when they tell us that e at 1 equals 3, now remember that means that's a coordinate point, 1, 3. The function follows this rule for any numbers a and b. So my suggestion is if you were having trouble with it and didn't know where to start, just watch through A. I'm going to do the whole thing, but just watch through A and try to apply it to B, and then try to apply that. And if not, watch the part of the video for B. Then try it for C, okay? All right, so e to the a plus b is the same thing as or is equivalent to e of a times e of b. All right, so if I'm looking at this first one, the way I did it, let me look at my notes. So I said, okay, e of 1. I want to show that e of 0 equals 1, but I know that e of 1 is equal to 3. Okay, so I know that this is 3. But I also know that e of 1 in this form could be e of 0 plus 1, okay, which then could be e of 0 times e of 1. All right, well, that's helpful because that's telling me that 3 is equal to e of 0 times e of 1. Okay, we know that e of 1 is equal to 3, so therefore, if I come over here and switch colors, 3 equals e of 0 times 3. I can substitute 3 in for e of 1. Then multiplication, I can divide here by 3 on both sides, and so e of 0 is equal to 1. Looks tricky, but it's not really. It's just asking you to apply a definition. Okay, so for e of 4, little bit harder. But now I know that I have that e of 0 equals 1, okay? So I know that if I made a table for myself, that means that when x is 0, y is 1. And I know that when x is 1, y is 3. All right, that helps me because now I can use that to expand e of 4. So I know e of 4, using the definition, is equal to e of 1 plus 3. All right, which is equal to e of 1 times e of 3. Okay, are we good with that? So e of 1, we already know is 3. So this gives me 3 times e of 3. Now I've got to break up e of 3. It's really kind of cool now. E of 3 could be e of 1 plus 2, right? All right, I'm going to come over here. So I'm going to come up. I'll just do it here. So then this would be e of 1 times e of 2. We see that? We just applied the definition. So now I'm going to come up over here. Okay, so that gives me 3 times, I can substitute 3 in again, times 3 times e of 2. All right, I'm going to have to do this one more time because e of 2 I could rewrite as e of 1 plus 1, which would be e of 1 times e of 1. So now we can see that we've got 3 times 3 times 3 times 3. And so that would give me 81. Okay, so e of 4 is 81. What would e of 2 be? So I challenge you to think about that, okay? And what would e of 3 be? I challenge you to think about that. All right, so C, now I want you to try it, but if you're on C and you're struggling, this is just some notation for myself to like think about. Okay, so e of n is equal to 3 times e of n minus 1 for any n. So they want us to show that. So I'm going to start by doing e of n. Well, if we think about it, the way we did this, we always did that number and then 1 less than the number. Like up here, I took 4 and I did 1 plus 1 less than that number. So I'm going to do that. I'm going to write it as e of 1 plus n minus 1. Okay, so that's going to give me e of 1 times e of n minus 1. And therefore, we know e of 1 is 3, so 3 times e times n minus 1. Remember, n minus 1 means like 1 less or the previous term, okay? Then it asks us to write a function rule for e to the x. Well, to be honest with you, for me to write a function rule, I wanted to think about the pattern to the numbers I had. So if I said that these were x, then this would be e of x. The numbers we had would be 0, 1, 1, 3, 2, 9, 3, 27, and then 4, 81. And so in looking at this pattern, I can see that this is going up by being multiplied by 3 every time, right? So times 3, and so on. So this tells me when I'm multiplying by the same number over and over, that's actually an exponential function. An exponential function is when each term is multiplied by a ratio, right? And so a function rule for that would be e of x equals 3 raised to the x power. So I'm going to test that out. So 3 to the 0 would be 1, 3 to the 1 would be 3, 3 to the 2 would be 9, 3 to the 3 would be 27, and 3 to the 4 would be 81. If you couldn't get that far, you could say something like this. You could say, if you couldn't write a function rule, you could say, okay, so e to the x is equal to 3 times the previous term, right? So for example, if I'm here, this was 3 times the previous term. If I'm here, it would be 3 times the previous term. If I'm here, it would be 3 times the previous term. So if you can't come up with the equation, you could at least come up with the words. So thinking of the rule of 4, okay? All right, hopefully that was a helpful video for number 17 and number 20. Have a great day.